In this video, we're going to be talking about and practicing synthesis using alkynes. So I've drawn 4 problems on the board. If you want to pause this video and see if you can figure these out, and then we will go over them. So let's start with this first one here. So I notice I'm going from acetylene, which is a 2-carbon group, to something with 1, 2, 3, 4, 5, 6, 7. So I've added 5 carbons onto this chain somehow. That should be an indicator that we've done the alkylation reaction. So we've added 5 carbons. We've somehow deprotonated this and added 5 carbons. That means this will be a terminal alkyne. If we think that this is a terminal alkyne, so this could potentially be coming from this terminal alkyne here. So we've added 5 carbons. We have 1, 2, 1, 2, 3, 4, 5. So we've somehow gotten from here to here. We've added 5 carbons. Now we've somehow gotten from here to here. So we've added a ketone internally. So that would be a Markovnikov addition of an OH, which would be be that enol form, which would tautomerize to the ketone. So if we're thinking about what reactions we could do to get from step 1 on this first step, we've done the alkylation, which means first we're going to add NaNH2 or NaH. And then we're going to add our methyl or primary alkyl halide. In this case, it's a 1, 2, 3, 4, 5 carbon chain. So we have 1, 2, 3, 4, 5. And then I'll just choose to make this an alkyl bromide. It could be an alkyl chloride, alkyl iodide, whatever you want it to be. So we've tacked on this 5 carbon chain to make it a 7 carbon total species. Now we're going to go from this species to this terminal product, which means it looks like we've tacked on an OH at this position right here. This would be a Markovnikov addition of OH, which means we can do this with, say, acid-catalyzed hydration, H3O+. We can also do this through oxymercuration reduction. So that would be mercury sulfate and water, followed by NaBH4 and NaOH. So this would be the total synthesis for that step. Going from this geminal dihalide to an internal alkyne, we've gone 1, 2, 3, 4 to 1, 2, 3, 4, 5, 6. So we've added 2 carbons. That's an indicator that we've done an alkylation reaction as well. So we've probably added these 2 carbons here. If we're looking at this species here versus this species here, it seems that we've taken this alkane and turned it into alkyne. So it looks like we've done a double dehydrohalogenation. So I would say we could add excess NaNH2 followed by a water workup, which would doubly dehydrogenate. Here's the 2 H's that we'd be pulling off. So we'd doubly dehydrohalogenate. We end up with this alkyne here. Now we need to add a 2 carbon chain. So similar to the example above, we're going to do an alkylation reaction. So first we would add NaNH2 to deprotonate that terminal alkyne. And then we would add the appropriate alkyl halide. In this case, it's a 2 carbon chain, so I'll just call it the alkyl chloride. So this would be our synthesis for this reaction here. In this species, we have 1, 2, 3, 4, 5, 6 to 1, 2, 3, 4, 5, 6. So we have the same number of carbons. So we haven't done any alkylation reactions. However, it seems that we've gone from an alkyl halide, a terminal alkyl halide, to a terminal alkyne. So we've turned an alkane into an alkyne. The only way we know how to generate alkynes is from the double hydrohalogenation reactions, and the only way we know how to make double add 2 halogens is to add 2 halogens to an alkene. So this is probably going to go through the alkene. 1, 2, 3, 4, 5, 6, which means we'll get it to the I'll use the dibromide. That's going to be addition of Br2. And we can do the double dehydrohalogenation of a vicinal dihalide to get to the terminal alkyne. So if we're thinking about what would do this final step is going to be excess NaNH2 in our first step, followed by a water workup in our second step. To get from the alkene to the dibromide, that's going to be Br2 addition. And to get from the terminal alkyl iodide to the terminal alkene, it looks like we're doing some kind of E2 elimination. But this is, if we do this with a strong nucleophile, we're going to get SN2. So I would do this with something like MEOH and heat to indicate that we're doing, we're doing an SN2 or an E2 reaction versus an SN2 reaction. Finally, to go from this species to this species, it looks like we've tacked on 1 carbon here. And we've turned the alkyne into the cis alkene. The only reaction we know how to generate cis alkenes is from the reduction of a alkyne using Lindlar's catalyst, so we're probably coming from this species here. And it looks like to go from this terminal alkyne to this internal alkyne, we've added 1 carbon. So that's going to be an alkylation reaction. So first we'll do NaNH2, followed by the the chain we're adding on. So this is going to be CH3Cl, we'll call it. So we're going to add a 1 carbon chain. And finally, to get from the alkyne to the cis alkene, we're going to need to do H2 on Lindlar's catalyst to make sure that poison catalyst only reduces it to the alkene and not to the alkane.